The following presentation is an introduction to a revolutionary concept that we developed here at ON Semiconductor called MARS. MARS stands for Modular Automotive Reference System. I'm your speaker today. My name is Steve Harris, and I'm the Senior Manager for the Image Sensor Automotive Ecosystem. I also like to describe this role as basically everything from end to end in the image sensor path. Here at ON Semiconductor, we develop best-in-class automotive image sensors, and we could go off and develop the best-in-class 8 megapixel, 4 megapixel, you name the resolution sensor, but if the lens isn't there to support it, the serializers and deserializers cannot support the bandwidth and the frame rate resolution combination, and the SoCs aren't there to support and process all of this video, then none of the ecosystem works. So my job is really to manage from end to end the system solution. And you'll see that throughout the course of this presentation on MARS, the Modular Automotive Reference System. So first, I'd like to talk a little bit about how customers in the automotive space develop with our image sensors. In the laboratory setting that you can see here on the left, we have what we call our standard demo system. It's called Demo 3. Every single sensor has a headboard that plugs into this Demo 3, and this Demo 3 plugs into the PC, which has an industry acknowledged best-in-class software tool called DevWare. DevWare allows you to program settings of the sensor, whether it be gains, gain ratios, integration times, various different parameters, frame rate of the sensor in a very simplistic way, and output that to the sensor so you can test with it. And in the laboratory setting, customers traditionally have a color chart to test for color accuracy, contrast for testing the sharpness of the image, light levels to test for different high light scenarios, low light scenarios, high dynamic range scenarios, and then of course the different light types, whether it be indoor illumination or just plain sunlight. And so again, this is a great approach for really testing the true performance of the sensor, and then also developing and creating settings for the sensor. Now, in the real world, what our customers will do and partners will do is they'll spend tens of thousands, sometimes hundreds of thousands of dollars, if not more, to actually take what we've developed here on our headboard, produce it in a module, and then mount it to a vehicle. So again, what we provide here, and I think what the industry is good at providing here, is different from what our customers are actually doing. And this is the problem that, as we get into, MARS is trying to improve. So if you think about the automotive space and image sensors, there are so many applications and such a diversity of different types of ways that the image sensors are used in automotive. There's your traditional backup camera and surround view camera that have been around for a while. In the forward viewing space, you can be doing things like collision warning, lane departure warning, high beam control, adaptive cruise control. On the side, you have your mirror replacement, which is now a growing market. And then additionally, in the car, you have things like passenger monitoring, drowsy driver detection, even airbag deployment based on body positioning is a new emerging market. So you can see here that there's potential for more than 20 image sensors in the automobile. And if you look at every single one of these applications, they all have different requirements. And we'll get into some of those different requirements later. But really, this is the importance of why we're developing this MARS system, because it's a flexible system, a modular system that allows you to mix and match different components for all of these different applications that you see here. So taking a look at one of the more tedious applications to develop for, a surround view application. Traditionally in a surround view application, you'll have image sensors located at the front of the car, the back of the car, and front of the car and the back of the car and the two sides. But there could be also different positioning of the surround view sensors. The bottom line is that you have 4 sensors that need to operate in parallel simultaneously. So if we take a look at the various components of this system from an imaging perspective, and I want to mention that very strictly, is that we're just taking a look at the major imaging system components. Obviously there are power and discrete components surrounding this here, and noise protections, etc. But if you take a look at the major components, you have 6 major components. The first one is the lens, which is a very critical part and component of the imaging system. Different lenses for different types of sensors, different fields of view for different types of applications. So a very critical component in the system design of an image sensor in automotive. Obviously you have the sensor, and the sensor can range from different resolutions to different frame rates to certain features for different markets, as well as different optical formats. So there are many variations in the types of sensors that you can use. Additionally, what you may see in the camera module side here is also the image coprocessor, which could be producing the color pipe and other functions such as lens distortion correction and tone mapping. This is something that traditionally you see in viewing applications where people need to visibly see the image, but you may not see when there is machine vision, meaning that the car is doing a function that you don't need to see the image for, like a lane departure warning. Oftentimes these camera modules sit at long length away from the actual electronic control unit on the vehicle, anywhere from, let's say, 10 meters from the actual electronic control unit. And so what is needed on the camera module side is a serializer, and this could be an Ethernet PHY, or it could be using an LVDS protocol from some of our partners. But this is what you traditionally will see in a camera module. Now, from the imaging perspective on the electronic control unit side, what you'll see is a aggregator. We could have a one-to-one serializer, deserializer, but that would add extra components. So what normally you see is an aggregator that will be a 4-to-1 deserializer. And in the case of this surround view, it's very critical that all of these cameras be in synchronous operation. And then last but not least, the important component is the application processor, or the SoC or FPGA, that would be in the surround view system, potentially stitching all of these images together and doing some distortion correction for the viewer or the driver or passenger. So again, there's the 6 major components that you have here. As I had mentioned, all of these applications really require different setups. So this is where MARS comes in, and this is how we're trying to solve the approach of giving people the ultimate amount of flexibility, reducing time to market by giving people evaluation modules that are very similar to what they're using in the vehicle. So the 6 components that you saw on the previous slide are all mentioned here. So MARS is this 3-board setup that you see here. The lens is connected with an M12 barrel. That's a very standard barrel for lenses in automotive, which means that for different types of applications, or if you prefer different lens vendors, you can choose your lens type. And I'll give an example here. Surround view, you may have a 190-degree field of view lens. In forward viewing, you may have something maybe a bit more narrow, 105 degrees or 45 degrees. So it all really just depends on the type of application that you're developing for. Secondly, is the sensor. So again, we have many different types of sensors across the board, from 1/4 inch, 1/3 inch, 1/2 inch, things that are more specific for viewing, some that have safety functionality built in. So there are a variety and plethora of sensors that we develop. This sensor board here exists for every single one of ON Semiconductor's automotive sensors. In the middle here, you see, again, the item that I mentioned that's optional, which is the coprocessor. And the reason, again, I mentioned that it's optional is traditionally you will not see this in an ADAS or machine vision application, because people would usually like to deal with a raw image for the machine vision. They don't need a visible image. And then last, you see the serializer board here, and this is what allows us to be able to connect from a long distance. And this connector that you see here that connects from the sensor to the coprocessor is also the exact same connector that connects into the serializer, so you really can eliminate this board here if it's not needed, and this connects directly here. Now, I talked a bit before about our best-in-class tool set. We also can take this this long stream video, and we can deserialize it, we can adapt it, and we can plug into our DevWare. So if you wanted to drive this with our best-in-class tools in a real vehicle situation, we give you the ability to do that. And last, I'll just mention that these boards are miniaturized. They're 25 millimeter by 25 millimeter, so they're form factor compatible. And again, they exist for every single one of the sensors that we develop and coprocessors we develop. And we work with the major serializer and Ethernet vendors in the market to make sure that you have the ultimate flexibility in terms of connectivity. Now, also, the real benefit too here is that you can take this exact same system, and then there's a variety of ecosystem partners that we work with. They all have some sort of electronic control unit or motherboard that they develop with. And most likely they have a deserializer from one of our partners, whether it be an Ethernet or whether it be one of the vendors in the LVDS space. They'll have that on their board, and then they'll have their application processor and SoC. And again, traditionally all of the companies that we mention here have something like this. And so what now you're able to do is we're giving you a system that plugs and plays directly into the electronic control unit, so you don't need to go off and develop all of these boards on your own. So that saves you time, saves you costs, saves you R&D effort, manpower resources. Additionally, most of the work from the serializer and deserializer is done by us, so there's no need for that bring up, or the bring up time for that is extremely minimal. So we're really bringing to you a system that is like what you would develop on your own, and we're really optimizing the time for your real-world development and testing. So I just want to give an overview again of the type of systems that we offer here, and kind of an analysis of how those systems work in each scenario. So on the left here is again the laboratory setting that you saw at the beginning. Our headboard that we use for every single sensor and our eval tools are great for sensor tuning, programming settings. They're good for low light and high light, dynamic range type lighting testing, and also the different types of light that you may see. Again, you're using our standard DevWare tools. We have things like headers and jumpers. You can do things like interface selection and power management. So it gives you a lot of flexibility in terms of what you're able to do in terms of testing and developing with the sensor in the lab scenario. Now, MARS will give you the ability again to plug into our evaluation tools, but because the system is miniaturized in a 25 by 25 millimeter, we just aren't able to bring out headers that allow you to connect up to things to measure power or to select interfaces. So we will have predefined interface selection on these eval tools with MARS. So you can still again use it with our standard tools here in the lab scenario. You just may not have some of the ability that you would with the full suite. And then last but not least, a rare scenario where you'd want to have the electronic control unit and you want to bring it up in a lab before you go out and drive with it. Again, you have everything available to you in the kind of laboratory setting, but you just wouldn't be using our standard tools. Now over here on the right, as you can see, the problem that you have with the traditional sensor company eval tools is that they're burdensome, they're cumbersome, they're large. So mounting on a vehicle is not very practical. If you try to do it, you may be able to capture video into a PC or a Mac or whatever system you're using. But again, it's very difficult, cumbersome, and large to do. Now, if you're using MARS with our eval tools, because of the miniaturized size of the MARS, because of the cable length, you're able to do that. You're able to mount the sensor and do more environmental type testing and system analysis. But because you're actually using the eval tools inside the car and the PC, you may not have the smallest form factor that you need. And of course, because you're using our tools, you would not be connecting into the electronic control unit or SoC. Now, the optical scenario in the car here is that you can connect into the ECU. You may not have the PC video capture, but most electronic control units will have an ability for you to capture into their hard disk drive. And so now you can mount the sensor, do your environmental testing, system analysis, small form factor, and you get your connection, that seamless connection into the electronic control unit. So a quick overview on what the out-of-box contents are for MARS. The first and most important part is really the documentation package that we give you. That's all free of charge. We give you the schematics, we give you the Gerbers, we give you the BOM, we give you all the sensor documentation, of course under NDA. And the reason that we give all of this away is because we also realize that people are mounting these in high volume quantities on cars. And so if you have a preferred PCB vendor that you'd like to manufacture these boards with on your own, but you have a tried and true system that you can utilize, you can go off and do that in high volume quantities. And you don't have to come through us. You can just get the documentation package and work with your own preferred vendor, saving you cost, and again, you're working with somebody that you already have experience with in terms of PCB layout and everything and so on and so forth. The documentation on the SerDes or the Ethernet PHYs really needs to come from the supplier, but I will say though, if you connect into our DevWare platform, it is transparent, so it happens seamlessly. But for the register setup, for us to release that, we need to put you in contact with the individual vendor. You still have access to our best-in-class DevWare platform. That's not going to change, so you have all of the flexibility in terms of changing a lot of the sensor settings with maybe exception of the interface. So that's completely available to you. We ship a standard 1 meter LVDS cable or Ethernet cable with the serializer boards. Now, if you want to go off and develop with a longer cable length or a custom cable length, we can also give you guidance on where to go to get those custom cables. But we realize that for every application, there's a different cable length, so we just provide you with a standard cable to get up for testing. An additional item that we give you is a 3D printer CAD module. We understand that practically for every different location within the vehicle that you may have a different ID design for the actual module itself. We'll give you a reference. You can go off and develop your own using our reference, or just develop your own using your mechanical engineers or using a house that you already work with to develop these modules. And finally, just as a summary, really MARS is solving the issue of giving you a real-world automotive imaging development tool. It's small, it's easy to mount, you can connect it all the way up to 10 meters away using some of the existing standards. It mounts directly into the electronic control unit and the SoCs and the application processors. And additionally, you can still even use our best-in-class tools. And it's flexible, meaning that you can use it with every single one of our automotive sensors. If you'd like to mix and match and test sensors against each other, you could do that. And similarly with our image coprocessors. And you have choices between the multiple different types of connection protocols and vendors based on your personal preference or what the electronic control unit is already using. And then last, we give you the full suite. So there's two methods. One, you could go off and develop your own MARS boards based on our recommendations and work with your preferred PCB vendor. You can get these contents from us. If you want to go off and do your own schematics and maybe miniaturize it to whatever you like, you have a much easier reference to utilize than something that's a lot larger like a standard headboard or development board that we give you. So I really want to wrap up there. I want to thank you for taking a listen to our presentation here. We really think that MARS is a revolutionary tool in the industry that's going to really speed up development and allow people to develop with our image sensors much easier. And we hope that this presentation has been enjoyable for you. Please contact local sales for ordering and more information. And thank you once again.